What's up, guys? Welcome to the video. Today we're going to start a new series on this channel talking about product architecture. So before we get into any specific API designs, we're going to talk about all the major concepts such as HTTP calls, WebSockets, RPCs. Then we'll talk about API architectural styles, security, idempotency, and we'll do this so we cover all the major ideas before we start designing. So hopefully you enjoy this. Let's get into it. So let's start with an example. Say Alice, a waitress who serves customers their orders. So here we have Alice, and a customer makes an order. Can I get a cafe Americano, right? Alice then takes that order to the kitchen with the instructions, Table 10, Customer A, 1 cafe Americano. The chef in the kitchen then prepares the order and hands that to Alice, who then gives it to the customer, right? So, like Alice, the instruction set architecture, which is an interface, is the intermediary between hardware and software of a computer system, right? So here we have our ISA, and we have our operating system, which is on top of it right here. And then on top of our operating system, we have these different applications, right? And there are two types of instructions that can be called, or that can call the ISA, right? Some instructions are privileged and it can't call the ISA directly, or it can call the ISA directly, but applications can't make those privileged requests, right? So only the operating system can make privileged requests to the ISA to get tasks done. So for example, setting a variable to a memory address, and then some requests can come straight from our applications, right? So system calls are performed by the application programs that are installed on top of the operating systems, and they themselves can call the ISA for some non-privileged requests, right? So this idea of standardized interfaces are pretty common in the computing world, right? So say you have a class and you want to get some work done, and with that you can just call the class, call a public function of the class, and have that work done, right? You don't need to really understand what's going on under the hood of a class. You know, we do it all the time when you are in a programming language and you want to parse a file or use a library. You don't need to understand the whole library or the whole interface that you're using. You just need to know how to call it, right? And same with distributed systems, right? So say you want to use Google Drive and you want to upload all your photos and videos to that. You don't really need to understand how Google Drive works. You just need to know how to use the interface to access Google Drive, right? So let's talk about application programming interfaces, APIs. So an application can request the services from another application without understanding the architecture of the other application, right? So say in this example, our customer here doesn't really need to understand how the kitchen works or how orders are being fulfilled. He just needs to know how to make the request or how to make an order, right? And so in this scenario, our customers are our client. Alice is our API interface between our client and our backend, and our kitchen and our chef are our downstream services and maybe even our database, right? So what are the benefits of using an API, right? Well, there's complexity abstraction. You can change the internals of a service without changing the interface, right? So the client only needs to focus on the interface, right? So say you wanted to change the ingredients of an order or change the menu in our cafe example. Our customers don't really need to focus on what's going on in the back room, right? They only need to focus on making an order, right? Which is how we want it. And there's improved modularity. We can break down our applications into smaller applications or smaller services, right? So say in our cafe example again, what if we had multiple chefs? Like we had a line of chefs and they're all doing different tasks. Still, again, like our customer has no idea, they don't really care, right? They just need to know how to make an order. And this allows it to be flexible, maintainable, and reusable, right? So this also allows for efficient development. A developer can request services by making a call without needing to rewrite code, right? So say you are a developer and you want to have some specific service done, right? You don't really need to rewrite the whole service. Like if it already exists, you don't have to rewrite it. You just can call another API to have that work done, right? It also expedites digitization. So a lot of businesses now, they want to offer their digital services to the public. This speeds that up. And it also has controlled accessibility. So say you want to share this data to a few people, you don't want to make your API public. There's a lot of control there to only allow a certain set of users to access your data, or you can make everyone access your data if you want. So there's a lot of control there. So what are the different types of APIs, right? So there's public APIs, and these are obviously publicly available to everyone. It's freely accessible, right? And then you have private APIs, and this is for developers working within a company. They can use them, and these are usually internal only, and they have the highest level of access. And you have partner APIs, so for users that have a business relationship with the company, and they're usually purpose driven, right? So for example, say you work at a retail company and you are partnered with FedEx, right? And FedEx needs to access your inventory for some reason. Well, in that case, you would have a partner API for them to access so they can do some kind of service or get some kind of information that they need. Then you have composite APIs, which are, so it's when a developer needs data from a bunch of different servers. Without making a separate API call to each server, they can just make one API call, and then it'll access all the different servers that we need and get that information, bundle them up, and then send that bundled response to our client, right? So let's talk about the difference between microservices and monoliths. So microservices are our service divided into smaller components, right? These can be smaller services that can handle smaller functionality and communicate to different applications, right? And the pros of this are it's easy to manage, right? And it's also very flexible. You just have like a bunch of smaller nodes that are interconnected doing different tasks, right? And the cons of this are that it's very costly for our resources and for networking. So all this networking, it does play a part in our latency, and it does require more resources because we have to have different nodes, right? And there's also a security issue because there's like different points of entry for our services, right? Now for monoliths are when we just have one giant application that has everything. So our front end's in here, our back end, and our database is in here, right? And it's all in one code base. And the pros of this is that there's fewer components and it's easier to manage and deploy this because it's only one big application. You only have to focus on one big deployment instead of a bunch of smaller ones and having all of those smaller deployments align like in microservices. And it's also simple to test and maintain since all the components are closely coupled together, right? If you wanted to test, one big feature, it would be easier to test that than in a system of microservices, right? And there's definitely fewer security issues because there's only one point of entry. The con with using monoliths is that it's really hard to scale, right? Like it's hard to get a machine it's hard to vertically scale it. You need a pretty big machine to have all this functionality in one place, right? So let's talk about API gateways. An API gateway acts as our single point of entry for all API requests, right? It acts as a gateway. So if a client wants to access different services from here and from here, like it doesn't need to know all these different service names. It just can focus on our gateway. So it takes our client's requests and routes them to the appropriate microservice, and it gets the responses and returns a unified response to the client. So instead of the client calling each microservice individually and then putting all that information together themselves, they can just call an API gateway. It'll go call those microservices, bundle them together, and give it back to the client. And API gateways also allow for security, right? And authentication, rate limiting. So, one person isn't calling our APIs too much, and monitoring. So we can also see, how often our APIs are being called, which APIs are being called, and it's quite useful. So let's talk about API endpoints. So an API endpoint is the exact location where a service is being provided, right? So we have our APIs, right? So say this is an API. We need to know like the location in which we can access like a certain service, right? And API providers will define a set of endpoints to make those resources available. Like in a document or in a website, they'll usually tell you like, okay, there's this endpoint right here, answers, or say we have like a dash questions, dash content, right? There'll be different endpoints for that one service so we can access different functionality, right? So it's like the exact location where some service is being provided. So let's get into some questions so we can solidify our understanding. So question 1, what's the difference between an API and an endpoint? Well, an API is the method by which two software applications can communicate, right? It's the interface in which two applications can communicate, right? And an endpoint is part of the API, and endpoints define the exact location of the available resources. So an API uses these endpoints to make its resources available to its users. What type of applications are more suited for microservices? Well, applications that have these attributes. So say a client needs to interact with different independent subservices, right? Or say continuous development and deployment is needed. Or maybe the application is really large and it aims to scale in the near future. So monoliths are harder to scale. Or say you have different teams working independently. So microservices are very flexible. So that's the end of this first lesson. Hopefully you learned something. Thanks for watching.